Good day, Kyle here again, and this next video will review the laws of negative and zero exponents. Remember that positive exponents represent how many times to multiply the base by itself. In a similar way, you can think of negative exponents as how many times to divide by the base. Essentially, some base x raised to the negative m power is equivalent to 1 over x to the m power. If it helps, you can also imagine that the negative sign in the exponent is becoming the fraction bar. Another way you can also think about negative exponents is simply raising the reciprocal of the base, so 1 over x, to the m power. You can think of negative exponents in any of those ways, whichever you find easier to understand. If the exponent is 0, though, the law is very simple. No matter what the base is, if the exponent is 0, it equals 1. If you remember the properties from the last lesson or review video, you can actually prove this as well. We know that any number divided by itself is 1, so x to the power of m over x to the power of m is equal to 1. We also know that through the quotient of the same base property, x to the power of m over x to the power of m is equivalent to x to the power of m minus m, which would just be x to the power of 0. That proves that x to the power of 0 is equal to 1. Side note about the quotient of the same base property as well. This is technically just the product of the same base and negative exponent laws combined. Remember that an exponent in the denominator can be rewritten as a negative exponent. So this could also equal x to the m times x to the negative m. Applying the product of the same base property would get you x to the power of m plus negative m, or just x to the 0th power. Now let's get on to some practice problems. Try them for yourself and we'll go from there. All right, problem number 1 introduces us with a negative exponent, so no need to worry. This is just equal to 1 over 2 cubed, which we can quickly simplify to 1/8. Problem 2 is another problem with negative exponents, and remember that the negative sign inside the parentheses of the base means that the exponent also applies to that negative sign. The negative exponent tells us to move the negative 4 to the denominator, and we've got 1 over negative 4 squared, so we'll just get 1/16 as our answer. Problem number 3 gives us a problem with 0 as an exponent. Now remember that anything to the power of 0 is equal to 1, so to the power of 0 simply equals 1. Problem 4 includes a fraction. How fun! Here you can either distribute the exponent first, giving you 3 to the power of negative 2 over 4 to the power of negative 2, or you can take care of the negative exponent first, flipping the fraction to find the reciprocal, 4 over 3, and then squaring each, giving us the final answer of 16 over 9. Problem 5 introduces us to a problem with multiple terms. So let's just go through each term one by one to find our overall product. Nothing is happening to the 2, so that stays. M to the 0 is just equal to 1. Anything to the 0th power equals 1. And then we're left with n to the negative 4th, which is equal to 1 over n to the 4th. Multiply this all together, and you've got 2 over n to the 4th. Problem 6 is a bit of the same with multiple terms. Again, nothing happens to the negative 4. X to the negative 1 is going to evaluate to 1 over x, and y cubed is just y cubed. It can't be simplified any further. So we'll put everything together, and you've reached the answer of negative 4y cubed over x. I hope this video has bolstered your understanding of negative and 0 exponents. Thank you. Have a great day. Take care. And always ask questions if you have any.